Okay, class, in this lesson, we're going to learn about transforming exponential functions. Specifically, we are going to move an exponential function left and right and up and down and see what that does to our exponential function. So let's go ahead and get started. Okay, let's suppose we are to graph the function f of x is equal to 2 to the x power. Okay, well, to do this, the most basic thing to do is take values of x and just plug them into the equation. Okay, so let's go ahead and get started with 0. Okay, that's the easiest thing. So f of 0 is equal to 2 to the 0 power. So if we substitute x for 0, okay, anything to the 0 power is 1. All right, so then we have a value of 1. Let's go to the next one. If x is 1, right, 2 to the 1 power is just 2. And let's go to 2. If x were 2, then 2 to the second power means 2 times 2, which is just 4. All right, now let's go to the negative. We're going to substitute -1 for x. 2 to the -1 power is the same as 1 over 2 to the 1 power, which is just 1/2. And then lastly, -2, substitute for x, is 2 to the -2 power, which is the same thing as 1 over 2 to the second power, and that gives us 1/4. Okay, so let's go ahead and plot these points. First thing to do is plot 0, 1, okay? And 0, 1 puts us right about here. And then the next coordinate is 1, 2, okay? 1, 2 puts us at right this point here. And I probably should label these axes. 4, 6, this is 2, 4, 6, -2, -4, -6, and -2, -4, -6. Okay, and this is my y-axis, this is my x-axis. All right, so we've plotted 2 points so far. Let's plot this one. This is 2, 4, so that puts us right about here. Okay, all right, the previous point I just noticed was plotted incorrectly. That should be at 1, 2, which means that puts us right here. Okay, now let's go to the opposite direction, to the negative. When x is -1, my y is 1/2, so that puts us right about here. That's -1, -1, 1/2. And then the last point, when x is -2, my y is 1/4. So that puts us closer to the axis, okay? And if you were to do this with infinite number of points, you would see that this function would look something like this. Oops. All right, so that is our function of f of x is equal to 2 to the x. Now, here's a question. What would happen if we raise this function by a certain number of intervals? Okay, let me go ahead and just redraw this graph as one line. Okay, so let's go ahead and move this up. Let's say 1, 2, 3 intervals. Okay, so my reference point here is this right here. Okay, so we basically took it from 0, 1 and we went it up to 0, 4. Okay, well, how do we raise all of these points? Okay, this point was 2, 4. Okay, this is 2, 4. And to bring it up to where the graph is, we got to move it up 1, 2, 3 intervals. Okay, so my new point is going to be at 7. So that means I'm going to have to add 3 to my y portion of the coordinate. And let's take a look at this point here. This was 1, comma 2. And to bring this back up to where the graph is, we got to go up 1, 2, 3 intervals. Okay. So that means instead of at 1, comma 2, it's now at 1, comma 5 plus 3. Okay. And let's take a look at this last point. This was at 0, 1. We went up 3. So we had to go up 3 intervals to get to 0, comma 4. So this is plus 3. Okay? So as you can see, the rest of these points, they move up plus 3. Well, what does that function look like? Well, if we were to rewrite that function, okay, this green function, I'm going to go ahead and change the color of this. All right, so this function is the same as what we started with, 2 to the x power, but we just add 3 to our y piece, okay? So as you can see, if we were to shift this function up from where we started and we go up 3 intervals, the only thing that's different in this equation is that we have a plus 3. So that tells us that if we move the function up, we're going to have a positive number of intervals, okay? Now the opposite is also true. So if we start out over here at f of x is equal to 2 to the x, which is what we originally graphed, and we shifted down 1, 2 intervals, for example, then this would be 2 to the x minus 2, okay? All right, now let's take a look at what happens if we shift this function, the original function, left and right, okay? So let's go ahead and redraw that graph. So that was this, okay? And let's suppose we move this, let's suppose we move this 2 intervals. Okay, so now our new point is going to be right here. Okay, so that's our reference point. We started out at 0, 1, and now it had shifted over to 2, comma 1. Okay, well, how do we get this 0, 1 to be 2, comma 1? Well, if we were to change this number, the x value, to 2, would that answer the question? Well, let's take a look. So I'm going to add 2, okay, and what would happen to the function? Well, this would now be, the x would now be 2, so we would say 2 to the x power, or 2 to the 4 power, 2 to the second power, which would be 4. So that means at 2, it would be up at 4. But that's not really the case here. That doesn't work, right? Because when we shift this to 2, our y value is still 1, okay? So that doesn't really work. So then what is the answer here? Well, what if we played around with the exponent here, okay, to the exponent? Meaning, if we change the equation so that this function is equal to 2 to the x minus 2 power, okay, to the x minus 2 power. What would happen if we plugged in a value of 0, okay, when x is 0, or I'm sorry, when x is 2, okay? That's where this is here. Well, at f of 2, I'm going to go ahead and create a new chart here. Actually, no, I don't need to do that. My apologies. So at f of 2, okay, if we plug that in, we now have 2 to the 2 minus 2 power, which is 0, and 2 to the 0 power is 1. Okay, so then our new f of x is now 1, okay, which is exactly what we want. Now let's take a look. Let's test out a few more components. So if we were to add 2 to this, now it's 3, okay? Then what would happen if we plugged in 3 into this function? Well, this would be 2 to the 3 minus 2 power, or just 1, so that would be equivalent to 2, okay? And does that work? Well, at 3, the function with an x of 3 takes us to 2 on the y, so that works, okay? And let's try one more point. Let's add 2 to this. So let's say it is now 4. 2 plus 2 is 4. So what would happen if we inserted 4 for x into this function? Well, if this is 4, then 4 minus 2 is 2, so that means this would be 2 to the second power, and 2 to the second power is 4. Okay, so do we get 4 here? Do we get 4 here? Okay, well, let's take a look. As the previous point gave us 2. So at 4, okay, we should go all the way up to 4, which it does. Okay, so then what does this tell us? Well, when we take a function, for example, 2 to the x power, and we shift it, right? We shift it to the right 2 intervals, we'd have to subtract 2 in the exponent, okay? And if we wanted to shift to the left 2 intervals, then it would have to be x plus 2, okay? So the signs change. All right, so let's go ahead and summarize what we've learned then, okay? So for a vertical translation, okay, or a vertical shift, the equation is going to be f of x is equal to the x plus k, okay, meaning that if it's a translation or shift up, it's going to be a positive number, however many intervals that is, and if it's a shift down, it's going to be a minus k, however many intervals that is. Okay, and then for a horizontal translation, or a horizontal shift, then our function is going to be f of x is equal to 2 to the x minus k. Okay, it's x minus k because if we are to shift to the right, okay, remember we had to subtract the x and the exponent. So a shift to the right would be a negative, so that means a shift to the left would be a positive, okay? So these are our equations for a vertical translation and a horizontal translation. Okay, now one of the best things to do if you don't see this is go to Desmos and graph this function and just start moving it around, and you'll start to see that these numbers will start to move in a way that makes more sense to you. Okay, hopefully that made sense. If this is not clear, please go back to the beginning of this recording and listen to it again. Thank you.